Hello everyone. So welcome to today's session, which is nested data structures in Python. Okay. So far we have seen strings, lists, tuples, dictionaries. Okay. So now today we are going to see nested data structures. Okay. What are nested data structures? A nested data structure is a data structure that contains another data structure as its element. So this is useful for representing complex data, like for example JSON data. So for API communication, for tabular data, and for hierarchical data. Okay, so why nested data structures are used? Let's look at some of these reasons. So one of the reason is to model real world hierarchical data. For example, users with multiple addresses, to handle JSON responses from APIs, and to group related data together. Okay, so one more is to perform efficient data processing and lookups. Okay, so uh, we already seen, as I have discussed, that we already seen lists, tuples, dictionaries. So now we are going to see advanced data structure, that is one data structure inside the another. So that is nested data structures. So what are the commonly used nested data structures? So here is the list. So some of the commonly used nested data structure is, one of them is list of dictionaries and dictionary of lists, dictionary of dictionaries, lists of lists, and lists of tuples. So you might be thinking, what are these? Let's see how do they look like. And so before seeing how do they look like, let's talk about a real world example of, in our day-to-day interaction, how these nested data structures come into play. Okay, so so let's consider a food delivery app. Okay, so you have opened Zomato or Swiggy, any one of the food delivery app, and you search pizza in the search box. What happens in the backend? So in the front end, you see the results, so list of all the restaurants, then you click on one restaurant, then it shows list of all the types of pizza and its prices, what are the ratings of the restaurant, and where it's its location. All those details you'll see. So in the back end, what does it happen? As soon as you type pizza, the request goes to the server. So the request, what is the request? The get request. So this is the get request. It will go to the server. Then the server will respond in the nested data structure. So here you can see it will respond with pizza, restaurant name, what is its rating, what are the items available, and how much its price, description of that pizza, like what type of pizza is it. So you will get a lot of restaurants, right? Not one. So you'll get list of all those restaurants nearby you. So that is the place where in the backend nested data structures are used. Okay, so this is one of the examples. So here you can see uh, it starts with a list, and inside a list you have dictionary. So this is called list of dictionaries. Okay, so here is an example image. As soon as you type pizza, so it gets you all the restaurants, what are the restaurants available. So as soon as you click one of the restaurants, it gives you all those details. So in the backend, how does it happen? So it brings all these metadata in the form of nested data structure, and it displays you easily. So you don't have to go through all these complexities as a user of this app, but this is what happens in the backend when the server responds. So this will be a live data. So similarly, we'll look another example, a ride booking app. For example, we have Ola, Uber. So as soon as you enter pick and drop locations, in the front view, what you see? You see cab types, mini, sedan, SUV, and the estimated fare, the driver details. So all these happens live. So how does it do? It does send a request. So as soon as you enter pick up and drop location and hit uh, uh, estimate or hit book, then it will send a request, then it will get back a response. So this response will be live, and you will get all these responses in this format. So you don't understand. So will you be able to understand in this format? No, we will not be able to understand this format. So what does this mean? So this is an API. So an application interacting with application. So when the app gets the response in this format, it parses and displays you in a format that is understandable to you as an end user. So in the backend, it uh, brings the nested data structure. So here you can see this is a dictionary. So it starts with curly braces. So inside a dictionary, we have lists. So you can see our value is in list. So it ends here. So this is a key of a dictionary, and this is the complete value. So this is a list. So this is dictionary of lists. And again, we have dictionary inside list. So it's like, if you see overall, it starts with dictionary, and then again we have a list. Inside a list, again we have a dictionary. So this is a nested data structure. So this is how uh, it happens behind the scenes. So this is example of Ola Uber app. So we'll see another example of train booking app. So let's say a scenario where you are searching trains from Hyderabad to Delhi on IRCTC app. Okay, so in front end, you see train name, its number, its timing, and what are the available classes with price. Okay, so what you do as soon as you enter the locations of source and destination and you hit enter, so behind the scenes, the application will get the responses from the server live, that these are the train available, this is the train name, train number, departure, arrival, classes, all these. So is this the data that you see on its app? No, this is not we see. We see in a plain, simple front end view, but in behind the scenes, this is what happens. So the API request and response happens through this data structure. So that's why this nested data structure are very important to build backend processes. So here you can see we have a list and dictionary. So this is list of dictionary, and we have dictionary of dictionary. So inside dictionary I have one more dictionaries. So this is combination of list of dictionary with nested dictionaries. And so this is how it brings back the data. So this is one of the example. So let's say one more example. So you might be using chat gpt or Gemini tools. So these are the AI tools that we search, we might use a lot. So you, let's say you entered one of the sample, like summarize this paragraph into key points, three key points. So what does it happen in the backend? So in the front end, you see just simple chat window with a search box. So as soon as you enter your complete paragraph, you paste it in the chat window and say summarize this in this paragraph into three key points. What happens is it takes your input and converts it into whatever the data structure it understands. So then what does it do behind the scenes? It creates a request body. So it says what model I should use. This is the message of the user. So users, this is the role. So chat gpt applications like chat gpt, Gemini, so they are role based. So when you write something, so it first takes what role you are taking. You can change this role and ask it to behave an expert role, something like that. Then it takes your content, so whatever you have entered into a dictionary. So complete request body like that you have requested through chat gpt, it takes your content. So this is the actual content that you entered. So it your paragraph and your what you are asking. So it takes your request body and sends this request body to the chat gpt LLM. Then behind the scenes, it you know uh, breaks down all those details, like what is the ID, what is the object, what are the choices, the role of assistant. Here is the summary, point one, point two, point three, and finish, reason, stop, index zero, what is the usage, and how many tokens. So tokens is number of uh, text uh, text that it has brought, number of words it has a user has entered, and number of words chat gpt has prompted as output. So the combination of all those is called total tokens. So total tokens is number of words. So this, when you enter something in chat gpt search, this is how it sends your request to the chat gpt server, and it will bring back the response in this format. But at the end, so is this what you see in the output in chat gpt a window? No, we don't see this. So this process happens in the backend. What you see is plain simple text of 3 points from that paragraph. So we ask chat gpt to bring 3 points from this paragraph as a summary. So it will display you just this, the content, in in a way that is understandable by you, reducing all these complexities. Okay, so what is this? This is a dictionary with a nested list of dictionaries. So here you can see this is a dictionary with nested list. So this is one list, and inside my list I have another dictionary. So this is a dictionary with nested list of dictionaries. Okay. So, so far we have seen the examples where these nested data structures are used. Let's go back to our main topic, which is the types of commonly used nested data structures. Okay, so what are the commonly used nested data structures? We have a list of dictionaries. So I have a list. Inside my list, I have dictionaries. So this is how it looks like. How do I access? To access my list of dictionaries, I can say students. So I'll pick my list of dictionaries and I'll execute. So as you have learned, in list we have indexes, but in dictionaries we cannot access dictionaries by indexes. We have to access it by its key. So since this is my list, I'm accessing my list by its index. So let's look at how does it look like when I just access my list with its index. So it brings this dictionary. So what I'm saying, I want just to output name Alice. So I'll access my dictionary. So this is my dictionary. So I'll access my dictionary with its key. So this is our key. This is the value. So when I access my key name, the value Alice will be printed. So let me run this. So this is how it will print. So next commonly used is dictionary of dictionaries. So here is my dictionary. Inside my dictionary, I have another dictionary. So how do I access my dictionary of dictionaries? So I can mention the key as to both keys in a nested way. So let's say I want to output bob at the rate example.com. So how do I access it? So I'll say users of. So when I first access user, let where is my bob at the rate example.com? Is it's in key 2 or user 2. So first I will access user 2, then I will access the email from the user 2. So what is the key here? Key is email. So when I access this, I'll get the output as bob at the example.com. Then another example we have is lists of lists. So a list inside a list. So this is an example of matrices. So so let's say you have a matrix 1 2 3 4 5 6. So I want to access matrix at index 1 comma 0. So what it will be? 3. Okay, so this is my 1. So this is my 0, this is my 1. Okay, so this is my 0 index, and this is my one index, this is my two index. So what I'm saying, from this zeroth index I have again two elements, that is 1 comma 2. Okay, so what I'm saying, 0 comma 1, again I have two indexes. So here I have two indexes inside my one index of 0 comma 1. So again I have two indexes inside my uh, second index, that is 0 comma 1. So what I'm saying, from 1, so from one index get me zeroth value, zeroth index value, so that is 3. So that is what we are getting it here. Next we have list of tuples. Okay, so here is my list, and inside my list I have tuples. So how do I access? So let's say these are coordinates. So I'm saying I want to access the coordinates 20. So how do I access it? So what I can say, so here is my coordinates. So this is my zeroth index, so this is my first index. So from this zeroth index I want to access the first value, so then this will be 0 comma 1. In this zeroth index I have two values, so that is 0 comma 1. So now I will access 0 comma 1. So from 0 I am accessing one value. From this is complete zeroth index. From this zeroth index again I have two elements, so that's why I am saying this is this value is 0, this is 1. So I want to access 1, so I'll get the coordinates 20. Okay, so in short, uh, we can see we have all these types of uh, nested data structures: list of dictionaries, dictionary of lists, dictionary of dictionaries, list of lists, list of tuples. Okay, so um, make sure you always understand what each level of nesting contains, like how to use indexing. So in lists we can use indexing, in tuples we can use indexing, but in dictionaries we cannot use indexing. We can use key values, that is the what is the key of that value pair. Okay, so okay, so let's see a sample example. Like here is the dictionary with tuples as keys and lists as its value. So, example. So here is a student score. So what I'm saying, Alice and Max. So student name and his subject is my key, and the list. So this is tuple, what I'm saying, in my dictionary. So this is my dictionary. Inside my dictionary, this is my key and this is my value. This is my key and this is my value. So you notice keys are in tuples data structure format, whereas values are in lists data structure format. So how do I access it? So to access it, I can say I can just print this. Okay, so if I print this, okay, so here already I have the example here. So I have the student scores along with their marks. So what I'm saying, access Alice math marks, math. So what I'm getting, 85, 90, 92. Access Bob's science, that is uh 1. So science at science 1 marks. Okay, so marks at first position. So I'm getting, when I'm accessing 1, I'm getting 88. Okay, so here consider this example. Maybe like Alice have got marks, he have written exam three times. So first time when he has written, he got 85. Second time he has written the exam, he got 90. Third time when he has written, he got 92. So here what I'm getting all the marks of Alice in his all attempts. So I'm able to get all his marks. But when it comes to Bob, what I'm saying, I'm saying get Bob science marks. So this is my key. Okay, and I'm accessing key, and what I'm saying, his first attempt. So this is first value I want to get from his marks. So Since in list indexing it will work, indexing in list indexing, so this is how it will work. So this is my zeroth position, this is one, this is two. So okay, so in terms I'm saying access his second attempt marks, so that is index one. Okay, so when I run this I'm getting 88. Okay, okay. So okay, so a quick recap. So you can focus on learning these concepts. So what is a list of dictionaries, why it's used, like it's used in API responses with multiple users or products. A dictionary of lists, it's used in filters, tags, group, data category. Dictionary of dictionaries, where it's used, user profile, system configurations, list of lists. It's using CSV or Excel like data, nested access patterns like accessing list along with the dictionary in multiple nested, if it is nested multiple times. So if you practice these and you'll be able to easily crack these nested data structures. So why it is important? As we have already seen in the above example that it's used in real world, and also APIs speak with the data structure. So there are a lot of APIs nowadays. And as a human being, if I want to speak to someone, so I'll directly speak and I'll get the information. But the applications, they cannot speak directly. So they talk in the form of request sent and response got back. So as they send the request in the form of a data structure, and they get the response also in the form of a data structures. So everything is nested here. So most real world data is not flat. So we have nested data, as we have seen in the example of food delivery app and ride sharing app, or train booking app also. So this is essential for job roles, whether you are looking for a data analyst, data engineer, Python developer, web developer. So this is very important even for DevOps engineer. So if they are configuring some system, so this might be very important for them to learn these nested data structures. So you need to work with API responses, files, configurations that use nested data structures. So if these are the work that you are trying to do or you want to do, you should learn nested data structures. So what happens if you skip this nested learning, nested data structures? So you'll get stuck handling with real world data. So a lot of real world data is live now. So there is no more batch. So now the real world data is the combination of batch and stream processing. So as soon as we request, we want the response back. So we are handling a lot of real world data. If you do not use nested data structures, you will face common errors such as key error, index error, type error, these types of errors. And you'll also struggle in interviews. So there are a lot of questions asked in interviews about nested data structures. You will struggle to answer these questions if you do not prepare for this, or if you skip this. So you have to parse these data structures using Python or any other language. You can use other languages also to parse these data structures. Okay, so finally, no, if you can, complete this nested data structure, understand how to use nested data structure, you can build a real world apps and APIs and data workflows. So it's one of the most practical and higher worthy skills that you can learn. Okay, so now we'll see some of the exercises to master nested data structure. So let's see some of the exercises here. Okay, so this is my uh, nested data structure. So this is a student data structure. So it's a dictionary. Again, this dictionary has nested dictionary, and again inside my dictionary I have a list also. Okay, here you can see I have a list also. So it's a dictionary and list. So here are some of the exercises that we will solve to uh, to learn our nested data structures in detail and get our hands dirty, and we'll understand how to work with nested data structure. So here I have compiled 30 different types of problems that you can solve to master this nested data structure. Okay, so we already learned dictionaries, lists, tuples, all those. So now let's use all those knowledge that we learn here to solve this problem. So here is our data structure. So let me minimize this to show you how does it look like. So this is the data structure. So using this data structure, we have to solve all those 30 problems, find out different scenarios regarding bringing name, marks, summing up, averaging, all those things. We'll see it one by one. So, okay. So first, let me run my nested data structure. Okay. So this is our students data structure. So it's a dictionary of dictionaries. So this is how it looks like. So it has a key. Main keys are this A101, 2, 3. So three IDs we have, three IDs and their student details. So we have three student IDs and student details here in this nested dictionary. So inside the dictionary, we have one more dictionary, and inside our dictionary, we have a list also. So now let's go to the first question. Print the name of all the students. Okay, so we want to print the names of all the students. So what are the names here? There are three names: Alice, Bob, Charlie. So I want to print the name, just the names of all the students. So how do I do it? So let me write this for s in student dot values. So if I execute this, so I'll get all the values. So all these values I'm getting it. So all these values. So I'm ignoring the main keys. Okay. Now from this dictionary, so this is the in nested dictionary. So I got the values as dictionary. So again from this dictionary, I want to just extract names: Alice, Bob, Charlie. So how do I do that? So I'll use this S. So I'll use S. Since S contains all these dictionaries, so I'll say S of name. So when I say S of name, I'll get only three: Alice, Bob, Charlie. Three names. That's it. So that is how we can solve this problem. Okay. So there is another way we can approach this. So we already saw list comprehensions. So this is a shortcut way of getting. So when I say S of name for S in student dot value, same thing I can write in list comprehension. So I'll get Alice, Bob, Charlie. So this is just one liner, makes our code easier, easy to read, and just in one line it executes. Okay, so let's solve our second problem. Okay, so what do we want? We want to get all the student names for student ID A101. Okay, so first let me get students. So what is our students? Okay, so this is our students data structure. So from this student data structure, so what I'm saying, I'm saying get list of all the students. So what are the list of students? So I'm getting all the keys, that is student IDs. Now from these keys, what I'm saying, pick first key because I'm interested in A101. So what I'm doing, I'm just picking first key. Now I'm getting the nested key. So inside my A10 key, I have again three keys, that is name, subject, year. So you can see name, subjects, and year, three keys. So from these, again from this, what I'm picking from A101, I'm saying just pick subjects. So I am interested in whatever the subjects we have. So when I execute this, I get two subjects, math and science. So next program I have is print the highest math score for Bob. So what I can say, I'll get student B202. Same way I can say I'll access student B02 and subjects and his math marks, and I'll say max. So when I say max, so I'll get 75. 75 is the highest math score for Bob. So same way, the fourth program is calculate the average science score for Alice. Okay. So first I have to get the science score for Alice. So this is how I can get student of the key A101. Since Alice in is in the student key A101, so I have to pick A101. Then I'll pick the subjects of Alice, then the science marks. So first I have to get his science marks, then I have to sum. I have to use the sum function to aggregate his science marks. Then I have to find sum of number by length of numbers. So that will get me the average. So here I can see I will get the average science score for Alice. So next is I need to add a new subject history with scores. So before adding, I'll show you what is my students data structure. So here you can see students data structure. So this is my student data structures. So what I'm saying, add history. So right now I have math, science, maths, English, science, English, but I don't have history. So now what I'm saying, add new subject history to C303, student ID 3. So let me run this. So here. So first, what I'm doing, I'm accessing this. I'm adding the subject, and inside the subject, I'm adding uh, another key called history, and inside that key, I'm adding two values, 80 comma 83. So let me execute this. So this is how it will look like. So before this, we didn't have history here. So after English, we didn't have history. Now we have added history to C303 student. Okay. So now next, let's look at another one. So let me add. So let me run students data structure. So this is our students data structure. So history remain as it is. What we are saying, at one index, index number one, I want to update English score to 90 for B202. So this is my B202 ID, and I have to go to the subjects. Inside the subject, I have to go to the English. So for English value, so this is zeroth index in my list. So this is first index in my list. So what I'm saying, at this place, 82 number, update the English marks as 90. So let me execute this. Now, if I run this, so you can see, so this value has been updated to 90. So here it was 82, now it's updated to 90. Now next, what we are saying, add a new student. So here we have three students, A101, B202, C303. Now what we are saying, add another student, D404. So his name David. Here is the subjects. Here is the year. So let's execute and run our students data structure and see. Here you can see student, an extra student D402 has been added. Now we want to say that delete student subject English. So we want to delete English record for student 302. So this is how the statement is. Delete student. We are accessing first key, that is student 303, 303, and second key, that is subject. The third key, that is English. So this way we can uh, delete student marks. So once we have deleted, let me run students data structure. Here you can see there is no English marks for student 3. Previously, we had English marks 80 and 90 for student 3. Now, there is no English marks here. Next, what we are saying, print all the students who are in the year 2023. So who are all in the year 2023? We have Alice, that is A101, and C. So two students are in 2023. So this is a list comprehension. We write it for S in student dot values. If S of year equal to 2023, bring their name. So this is how we are seeing. So if I okay, so if I run this, I'll get if I run this, I'll get Alice and Charlie. So Alice and Charlie both are in 2023. Now again, what I'm saying, create a list of all student names and their years. So from this nested dictionary, complete dictionary, so I want to create a list just with student names and their years, respective years. So how do I do it? I'll declare a list, and inside the list I'll call the uh, I'll call I'll call the student by their key, that is name, by their key year. And how do I get those keys from here? For s in student dot values. So when we say for s in student dot values, we'll get these. I mean these just these structures. So from that I'm picking name and year. So let me print this. So here you can see Alice, Bob, Charlie, David. Okay, so now we are saying create a new dictionary with only names and their math scores. Okay, so what I'm saying, math score equal to dictionary of s of name. Uh, I'm, I'm what I'm doing, first I'm getting values from here. So what will be my values? So these will be my values. So first this will be my value. So all these will be my values that will bring here. So this statement, first statement, will bring these values for all of these students. So from this values, we'll pick name here. I'll say s of name. So this is my s variable. So I'm saying s of name and then s of subject. So this will get my subjects. So from that subject, I'm saying dot get math. So I'm saying from that subject list, only get math and what are uh, scores. So when I print this, so I'll get all this. So let me just remove it for a second from here. Okay, so let me run it. So this is Alice and then math marks, Bob math marks, Charlie, David. So all these are printed here. Now next program we have is print all subject and scores for each student. For okay, so here you see for s in student dot values, print name and their subjects. So here you can see we are printing name and their subjects and their scores will also be printed. So now we're saying find the total number of subjects for each student enrolled in. So I want total number of students. So I'm saying the student name and number of subjects they are enrolled in. So for that I'm getting keys here, values here for student dot items. So you see Alice two subjects, Bob two, Charlie two, David two. So count how many students have taken science subject. So this is my sum of science in subjects. I'm saying for so this is my logic and this is my comprehension. So for S in student dot values, so how many science subjects we have? So I want to count. So sum of will be three students have taken science subjects. So how we can confirm it by rerunning our students dictionary. So how many students have science subject? So Alice, Bob doesn't have science subject. Charlie has and David has. So this is how we can get. Now our 15th program, list of students who have scored above 90 in any subject. So first I'll get for S in student dot value. So this will get me all the values. That is, this is my key, student key, and the value is this part. So I'll get all the values from that values. What I'm saying, for marks in s of subjects dot values. Again, I'm writing a nested dictionary to get just the subject values, and I'm writing a conditional statement. If any score greater than 90 for score in marks, print their name. So I'm just breaking my loop here. So let me run this. Alice and Charlie, both of them has marks greater than 90 in any subject. So next I have print the lowest score across all students for math. So I have math equal to all for s in student dot values, math underscore all plus subjects dot get math. So here I'm using for statement along with an increment. So I'm saying print the lowest score across all students for math. So if I run this, 70 is the lowest score. So I can see where is 85, 70. Okay, so 70 is the lowest score for math. Okay, so now what I'm saying, create a new dictionary with student names as keys and total scores as values. So from that original dictionary, I want to create a new dictionary. So my original dictionary is, so this is my original dictionary. So from this original dictionary, I want to create a new dictionary with just student name and some of marks as key value pairs. Okay, so Alice total marks, Bob total marks, Charlie total marks, Davy total marks. Okay, so this is how I can uh, perform my operation. So now next question we have, for each student print subject wise average. Okay, for S in students dot values. So what this student dot values will get. Okay, so we already seen. So let me show you quickly. Print S. So when I print S, student dot values, we'll get all these. So from this, we are extracting just the name. So when I extract name, I'll get Alice. Then again, from when I extract subject and marks, oh, I'm able to sum. So what I'm saying, sum of marks divided by length of marks. Okay, so let me comment this out. So if I finally run my program, so you can see Alice math 89. So here we are using floating point value as a formatting. So that's why we are able to see this 0.00. Okay. So next we have check if history exists for any student. So we want to check if the subject history exists for any of the students. So we have seen membership operators, right? Any. So this is one of those operators. So any of history. So this is my string. So in subject. So I'm checking any of the string, any of history subjects, history text history exists in subject. So I'm accessing subject by looping my student dot value. So if I uh, see whether it will bring me true or false. Okay. So next I have uh, another program, add computer science with an empty list to all students. So for uh, so what I'm saying, subjects dot set default computer science. So add computer science with an empty list. So I want to just add empty list. So here, this is how I can add it. So let's, before adding, check what is the students dictionary. How does it look like? So do we have computer science? So we don't have computer science here. So once you run this, and we can see computer science as an empty list to all students. So you can see student 1, student 2, student 3, student 4. So this is how we can add it. Now next program 21 we have is remove all scores below 80 from each subject. Okay, so here we can see we are extracting values from that values. Again, we are extracting subject values, and from that subject values, we are writing an expression. We are grabbing that in a variable and writing a list comprehension. So I'm checking if the are below scores below 80 from each subject. Remove all scores below 80. So what I'm saying, I want to remove all scores below 80 in each subject. So for that, I'm grabbing all the subjects that are greater than 80 only, then I'm printing it. Okay, so I'm printing all those subjects that are greater than 80 only. So there is no subject below 80 here. So now program number 22, you're saying write a function to get all scores of a student given ID. So I have written a function, get scores of student ID. So we are returning students dot get student ID dot get subject. So based on the given ID, it will return student ID and their subject. So let's query A101. So we'll get A101 has maths and it's marked science, computer science. And if you query another student, C303, will get the science marks of this given student ID. So now again, one more program is write a function to return names of students who have more than two subjects. Okay, so I have written a function. So we are returning, so whatever the value we are returning is a name of the students who has more than two subjects. So here is my logic. I'm grabbing those student names here. So I'll print my result here. So let me run it. So Alice, Bob, Charlie, David. So these students have more than two subjects. So now add a new score to specific subject for a student using a function. So I'm saying add score. So for B202. So let me check my students data structure. So B202, does it have history? So it doesn't have history here. So it has Mac, English, and computer science. So I'm doing a add score function. So already written. So this will append the history and its marks to the uh, B202 ID. So when I run it, so you can see B202 has history. So next we are saying replace all score with grade letters. So instead of showing scores, we are showing grade letters ABC based on scoring rules. So I have defined a function grade score, return A if score greater than equal to 90, else B if score greater than or equal to 80, uh, between 90 and 80. So we are saying B, below 80 we are saying grade C. So if I loop through, if I run it, yeah, I can print this. Okay, so we need to call this function grade, grad, grade. Okay, so I have to pass the number. So if I pass the number, I'll get grades based on the number I have passed. Okay, so I need to, so there is no grades here. So I need to, since there are empty lists, this is erroring out. So what I have to do, I have to redeclare my original students nested data structure. So let me redeclare it. So I'm rerunning this part again. So now let us come back here to the 25, 25. Okay, so let me come back to 25. If I run this, I can see instead of marks, I can see my list has been, my dictionary has been converted to grades, student grades. Okay. So similarly, uh, again, I have one more program, print only students who have all subjects with average greater than 85. Since my dictionary is converted to grades, again, this program will also error out. So again, I will go back and rerun my dictionary, original dictionary. I'll reset this. Okay, so I'll rerun this part. I'll come back to 26th problem, number 26th. Okay, so what I'm saying, print only students who have all subjects with average greater than 85. Okay, so only Charlie has average score greater than 85. Now what I'm saying, create a flat list of all subject names from all students, no duplicates allowed. So in this, uh, what I'm doing, subjects is equal to set. I'm converting my subjects to set. So I'm declaring a variable subjects and converting, writing an empty set. Then I will grab that into my set. So what I'm saying, for async student dot value subjects dot update. So what I'm saying, update all my set with subjects. So by default, what's the nature of a set? It will not allow duplicates. So since I'm grabbing all these values into a set, it will remove duplicates. So let's first see what happens here. So when I print this, so I'll get science in English. So let me comment out this also, print subjects. Okay, so I'm getting only two subjects. Create a file list of all subject names among students. Okay, so let me recreate my dictionary again. So let's see. Okay, so this is my dictionary. Go back to number 27 problem, 27th. Okay, so before running my problem, let me query my STUD, students. Okay, so this is my dictionary. So now let me run this sample program. So let me comment this out also. Okay, okay, so I'm able to get uh, all subject names from all student, no duplicates. Okay, so what are the subjects? Math, Science, Math, English, Science, English. So I'm getting Science and English. So where is Maths? Mm. So where is Math here? Maths, Math. Okay, for 27th problem, print flat list of all subject names from all students. So you can see we are able to print science, math, English. So these are all the list of a list of subjects. Now find which student has highest total score. So we are grabbing the total score inside a dictionary again, and inside the dictionary. So we are seeing dictionary comprehension. We are using it. We are grabbing. We are declaring our key, and this is my value. So this inside the value, I'm writing an expression. Sum of marks for marks in subjects dot values for s in student. So this is my nested dictionary comprehension. So I'm able to grab the total scores for each students here. So before printing, uh, so here we can see print. If I print total scores, so this is how it looks like. Alice 431, Bob 390, Charlie 364. So now what I'm saying, print max. So only the max score. So who got the maximum? Alice got the maximum. Then problem number 29, sort all students by total score in descending order. So sorted students, so we are using sorted function. So inside the sorted functions, we are bringing all student values, that is my uh, all the keys along with the student name, subjects, all. Then I'm writing lambda function here. So I'm grabbing that key here into the key variable lambda s. This is my key and this is my expression. So I'm doing a summation and grabbing all those values by writing this expression from the subjects. So I'll grab total score and reverse equal to true. When I write reverse equal to true, that means we are sorting in descending order. So when I run this, Alice, Bob, Charlie. So that is how sort all the student by total score descending order. This is how we can write a function. So next I have this is the last program. Export all student data as list of dictionary. So we are doing a flattened structure. So I'm declaring an empty list. So from this empty list, what I'm doing, I'm declaring two key and value variables and student dot items to grab those key and values in dictionary, and what I'm saying, entry equal to. So this is my variable. So ID equal to SID, name equal to S of name, year. So this is my formatting. So this is the formatting that entry dot update. So what I'm doing, I'm updating my list. So this is my list with subjects. So then again, I'm calling flattened, that is the declared list, and appending my list with entry. So this is how it looks like. So have successfully converted my dictionary, nested dictionary, into list of dictionaries. So this is how I converted it. So okay, so far we have seen uh, all these exercises to fully grasp the nested data structures. So those are list of dictionaries, list of lists, dictionary of dictionaries, list of dictionaries, dictionary of lists, and a list of tuples. So combine all those. These nested data structures are very important. Okay, so thank you for staying and listening to this session so far. So I encourage you to practice all these to get your hands on these nested data structure so that you are able to grasp the concept fully and able to solve the interview problems easily and solve real world problems also. Okay, so that's it for today. We'll meet tomorrow. Thank you. Bye bye.